Every single day, 460 U.S. Army soldiers are diagnosed with back overuse injuries. That's one soldier every 3 minutes. Not from enemy fire, not from combat, from the weight they carry. Low back injuries cost over 1 million. Lost duty days per year. That's an entire brigade worth of soldiers sitting out because their bodies failed before the enemy ever had a chance. But here's what the Pentagon doesn't advertise. Your skeleton isn't designed for modern warfare. A human spine can handle about 40 pounds of load before damage accumulates. Combat soldiers carry 120 pounds. The math is simple. Your bones are breaking. And they're breaking faster than recruitment can replace you. In May 2022, soldiers from the 101st Airborne lifted 800 howitzer rounds in the field. 60 pounds each. 4 hours straight. 2 weeks into field operations. By the end, most could barely stand. But some of them weren't exhausted. Some of them felt stronger than when they started. They were using something the military had written off as impossible. So what changed? And why are soldiers saying this makes them feel superhuman? Military recruits face a specific type of injury that civilian doctors rarely see. Bone stress injuries. Your bones aren't solid. They're a living tissue that constantly breaks down and rebuilds stronger. When you stress bone tissue gradually, it strengthens over time. That's how training works. But when repetitive stress happens faster than bone can rebuild, microscopic cracks form. Left unchecked, those cracks become stress fractures. According to U.S. Army research, bone stress injuries are most common in the tibial splints that turn into fractures and the femoral neck, where your thigh bone connects to your hip. Women experience these injuries at higher rates, particularly hip fractures. Men suffer more tibial stress fractures. The cause is always the same. Too much weight, too fast, too often, running with combat loads, marching with rucksack, lifting ammunition, repetitive high-impact stress without recovery time. The Army studied this extensively. They know the problem. They've known for years. Runners have a 15% injury rate, with bone stress injuries accounting for 70% of all their injuries. Military recruits have it worse because training ramps up intensity dramatically over just 10 to 16 weeks. Your body doesn't have time to adapt. The skeleton fails. And here's the terrifying part. Most soldiers don't report these injuries early. They're motivated. They don't want to be recycled, restarted in training or fail because of injury, so they push through pain until the damage becomes severe. By then, recovery takes months. The soldier is out of action. The unit loses capability, and the cycle repeats with the next recruit. For decades, the military tried to solve this with better boots, adjusted training schedules, lighter equipment. None of it worked. You can't make equipment lighter and still carry what combat demands. You can't slow training and still prepare soldiers fast enough. The solution had to be different. What if instead of reducing the load, you made the body stronger? In 2021, Professor Carl Zellick from Vanderbilt University received $1.2 million from the Army to solve a problem every previous exoskeleton program had failed to fix. The military had spent decades trying to build Iron Man suits, full-body, rigid, powered exoskeletons that soldiers hated. They were heavy, they restricted movement, they broke down, they needed power sources. They slowed soldiers instead of helping them. Zellick took a completely different approach. He spent months at Fort Campbell with the 101st Airborne, not designing anything Hustuachin, interviewing, understanding what soldiers actually needed. What he discovered was simple. Soldiers don't need to become superhuman. They just need their backs to stop failing. The result was SABER, the Soldier Assistive Bionic Exosuit for resupply. This thing shouldn't work. It doesn't add strength. It doesn't add power. And somehow it removes over 100 pounds of spinal load. The suit secures to your upper back like a lightweight backpack and attaches to your thighs with fabric sleeves. Elastic bands stretch between the shoulders and thighs, acting like artificial back muscles. When you bend forward to lift something, the bands stretch and store energy. When you lift, they contract and assist, reducing the load on your spine. The genius is in what it doesn't do. It doesn't try to make you stronger. It just redistributes the work. Your legs are stronger than your back. The suit transfers load from your spine to your legs and hips, where your body can handle it. Biomechanical evaluations revealed that this device reduced stress on soldiers' backs by more than 100 pounds while lifting. Read that again. It eliminates 100 pounds of spinal compression. The physics seem impossible, but the testing proved it works. It weighs 3 pounds. It has no motors, no batteries, no electronics. Just fabric straps, elastic bands, and a simple clutch mechanism. Additionally, most soldiers increase their endurance by over 60% while wearing SABER, not 6%. 60, they could work more than half again as long before exhaustion hit. And the soldiers noticed, how could they shift the conversation to something that ties this back to the original promise? Here's where the science gets interesting. Remember those bone stress injuries, the microscopic cracks that form when repetitive stress outpaces healing? SABER doesn't just reduce pain, it fundamentally changes the stress equation. When you lift 60-pound ammunition rounds repeatedly, your tibial bone experiences compressive strain. Researchers at the Henry M. Jackson Foundation for Military Medicine developed robotic surrogates to measure exactly how much strain different conditions create. They found that ankle-foot orthosis devices that support your lower leg can dramatically reduce tibial load and enable faster return to activity after injury. The same principle applies to back-supporting exoskeletons, but scale it up. By reducing spinal compression by 100 pounds, SABER reduces the repetitive stress that causes bone damage. Your skeleton experiences the load as if you're lifting significantly lighter weights. Over time, this means bones strengthen instead of breaking down. The Center for the Intrepid at Brooke Army Medical Center has been studying this extensively. They're redeveloping testing methodologies to measure how devices like SABER affect bone loading during the complete gait, cycle walking, running, carrying loads. The goal is understanding exactly how much protection these devices provide and optimizing them for maximum effect. But the real proof came from the field. Private First Class Dale Paulson, 101st Airborne, 320th Field Artillery, spent hours lifting 60-pound howitzer rounds. He said the suit gave him an extra boost, made him work less hard, helped him move quicker. Sergeant Alfredo Vela, same unit, was moving their howitzer 4 to 5 times per day, digging defensive positions, preparing fire missions. He reported the suit helped especially with lower back strain during all that heavy lifting. These aren't lab results. These are soldiers in the field doing their actual jobs, reporting that a 3-pound piece of fabric made them feel stronger. So why haven't you seen these deployed everywhere? After field testing in May 2022, 90% of soldiers surveyed said they increased their ability to perform job tasks. 100%, every single soldier said they would likely wear it if it were made available for everyday work. That kind of adoption rate is unheard of for new military equipment. Usually, soldiers resist change. They don't trust new tech. They prefer what they know. But with SABER, the resistance never materialized because soldiers designed it. The Army's Pathfinder program connected Vanderbilt engineers directly with 101st Airborne soldiers from the beginning. Over a year, more than 100 soldiers participated in designing and testing prototypes. When something didn't work, they said so. Engineers fixed it. The next version got tested. This iterative process created a suit that soldiers actually wanted to wear. The research and development has now moved from the Pathfinder team to the U.S. Army Combat Capabilities Development Command Soldier Center. DevCom is preparing the suit for manufacturing and robust field trial use. They're funding Heroera, Nashville-based company Zelic, co-founded to design and fabricate dozens of pre-production units, with plans to scale to hundreds of units for widespread testing. The Air Force is interested too. They're testing similar technology for maintenance crews who work on aircraft in awkward positions for hours. Mechanics bending over engines. Technicians reaching into tight spaces. All situations where back strain accumulates and injuries develop. The Royal Australian Air Force has already rolled out hundreds of HeroWare X, the civilian version of SABER technology, to reduce back injuries among their personnel. Studies show these executes can reduce muscle fatigue, enhance physical endurance, reduce back injuries, and improve worker productivity during repetitive lifting and bending tasks by 20 to 40%. But here's the critical question. If this technology works so well, why did it take until 2022 to develop it? What changed? What changed? What changed? The military has been trying to build exoskeletons since the 1960s. Every attempt failed for the same reasons. They tried to build powered suits, motors, hydraulics, batteries, complex control systems. The suits were heavy 60, 80, 100 pounds before you added any combat gear. They required constant power. Batteries died, motors broke, hydraulics leaked, maintenance was a nightmare. And they were rigid. Soldiers couldn't move naturally, couldn't run, couldn't take cover, couldn't perform combat tasks. The suits interfered with everything they needed to do. According to the CDC, exoskeletons can also pose new dangers: lack of mobility to avoid falling objects, potential falls due to shifted center of gravity, pressure points causing tissue damage. Researchers struggled to interface rigid exoskeletons comfortably with the human body, which has multiple degrees of freedom and deformable to. Previous attempts focused on technology-first design. Engineers built what they thought soldiers needed without actually asking soldiers. The result was impressive engineering demos that failed in real-world use. SABER succeeded because it inverted that process. Soldier needs first, technology second. Zelic's team started with a simple question. What is the minimum intervention that solves the maximum problem? The answer wasn't a powered suit. It was elastic bands and fabric. But the breakthrough wasn't just design philosophy. It was materials science. Modern fabrics are incredibly strong yet lightweight. Elastic polymers can store and release energy efficiently. Manufacturing techniques allow custom fitting without expensive tooling. The technology to build SABER existed for years. What was missing was the right approach. And now that approach is spreading. So where does this lead? Forget the Hollywood vision of powered armor. The real future of military enhancement is invisible augmentation. Devices so light and comfortable, you forget you're wearing them. Systems that enhance your natural capabilities without restricting movement or requiring power. SABER is just the beginning. The military is exploring similar technologies for every high-stress task. Upper body exosuits for lifting and carrying, lower limb devices for extended marches, specialized supports for specific roles: artillery crews, logistics personnel, combat engineers. The goal isn't creating super soldiers. It's preventing injuries, extending careers, keeping trained personnel in service longer. A soldier with 10 years of experience is exponentially more valuable than a fresh recruit. If an exosuit extends that soldier's effective career by even 2 years, the investment pays for itself many times over. Vanderbilt's research shows exosuits could also expand the recruiting pool. Currently, some candidates don't pass physical requirements for certain specialties. With assistive technology, Individuals who might not otherwise qualify could perform jobs that previously required exceptional physical capacity. Professor Zellick noted that when testing existing exosuits, lifting endurance increased by 25 to 75%. That's the difference between failing and passing standards for physically demanding roles. But the implications go beyond military applications. Industrial workers, warehouse employees, construction crews, healthcare workers lifting patients, firefighters carrying equipment. Any profession involving heavy lifting or sustained physical strain could benefit. HeroWare's civilian Apex 2 exosuit is already deployed in manufacturing and warehousing operations. The exosuit acts like artificial back muscles, reducing strain and fatigue by 20 to 40% using elastic bands to support the lower back during bending and lifting. This is the quiet revolution. Not dramatic, not flashy, just functional technology that makes people's bodies last longer doing hard jobs. And it's here now, being refined and scaled for mass adoption. But there's one final piece most people miss. The title promised bones stronger than steel. Here's how that's literally true. Steel yields under stress. Bend it too far, it stays bent. Stress it repeatedly, it fatigues and fractures. Human bone is different. It adapts. When you stress bone appropriately, it rebuilds stronger. Osteoblast bone building cells respond to mechanical stress by laying down new bone tissue. This is why astronauts lose bone density in zero gravity and weightlifters develop denser bones than sedentary people. The problem in military training isn't that bone can't strengthen, it's that the stress exceeds the adaptation rate. Soldiers load their skeletons faster than rebuilding can occur. By reducing that stress with devices like SABER, you bring the load back within the adaptive range. Instead of breaking down, bones strengthen. Over months and years, soldiers wearing exosuits could literally develop stronger skeletons than soldiers without them. Not because the suit is doing the work it's only providing 20 to 40% assistance, but because it keeps stress within the range where bones adapt instead of failing. This is what stronger than steel means. Not invulnerability, adaptation. A skeleton that strengthens continuously under load instead of accumulating damage until it breaks. And unlike steel, bone is self-healing. Minor cracks repair overnight. Stress fractures can heal fully with rest. You can't weld a broken eye-beam back to original strength, but bone tissue can regenerate completely. The battlesuit isn't replacing your skeleton. It's protecting it long enough to let natural processes make it stronger. SABER and devices like it represent the next evolution of military capability. Not bigger guns, not faster vehicles, not more firepower. Just soldiers who can do their jobs longer, better, and with bodies that last, because in the end, the best weapon system is a trained human who isn't broken. And if a 3-pound fabric suit can keep that human in the fight, it's worth more than any tank, jet, or missile system ever built. The invisible destroyer injury from the weight of war finally has an answer. And it weighs 3 pounds.